Hello and welcome to another fun-filled video of math with Mr. Sims. It's a pleasure today to bring you factoring trinomials. Now I thought you're thinking to yourself, I never thought this could be so much fun, and in fact, it is in fact as fun as you think it's going to be, except more times that by infinity, and that's about how fun it is. So factoring trinomials is a lot of fun because what we get to do is we get to take something that looks really complicated and just break it down in some beautiful pieces, kind of like Legos. You know, you have like a Lego model that you build. It's like the Starship Destroyer, right? And then after you, that's a terrible Starship Destroyer, but you get the idea. You have this thing and then you break it down into all the little Lego pieces that make it up. So anyway, that's what we're going to be kind of doing today. That's kind of what factoring really is. So without further ado, let me go ahead and get started with that. And we're going to do this in my writing layer. I like that. Okay. So first of all, first thing I want to tell you, factoring, when you do factoring, all factoring is really the opposite of distributing. So for instance, let me just give you an example. Let's say I had 3 times x minus 2. If I were to give you this and I said I would like for you to go ahead and distribute that to make it simpler in a way, then what you're going to do is you're going to distribute the 3 to the x and the 3 to the negative 2. So I'd get 3x minus 6. Once again, I multiplied 3 times x to get 3x, and I multiply 3 times negative 2 to get negative 6, right? And that's distributing, right? On this side, that is distributing. I'm going to go ahead and write it there. Distributing. That is way, way, way too big. Let me try and make that like way smaller. So let's go ahead and make that like 2. There we go. Distributing. So this is an example of distributing, right? But the other example is over here. Let's say I wanted to do factoring, right? Factoring is going to be the opposite of that. We're going to once again make that super small. So let's just go ahead and make that like super small. And here's going to be the example of factoring. So if we're factoring, I'm going to go ahead and get back to my writing layer. And I'm going to write, I'm going to start with my 3x minus 6 this time. And instead of going, instead of putting something into it, I'm actually going to take something out of it. And the way I do that is I say, well, what factors do these two have in common? And I'm actually going to look at my smaller number, and I mean smaller in magnitude, not actually by the number line, because if you look at the number line, technically negative 6 is somewhere over here. Let's say this is 0, right? Negative 6 would be here, and 3 would be over here. So technically negative 6 is smaller. So that's not what I'm talking about, though. I'm talking like the absolute value, just the magnitude of the number, ignoring the positive or negative sign. So I'm looking at this 3. 3 is smaller than 6, essentially, is what I'm saying, ignoring the negative. So I'm looking at this 3 and I'm saying, okay, what are my factors of 3? So if I'm factoring, I say, what are my factors of 3? And so I'm just going to go ahead and figure them out. 1 times 3 gives me 3. And really, there's no other whole numbers that multiply to give me 3. If I keep going, it'll be 3 times 1, but I already have that pair here. So all I'm getting now is just a repeat of this original pair. So my two factors that I can try to factor out of this are 3 and 1. Well, obviously, you can factor out a 1, but that doesn't often help you. So in this case here, what I can factor out is a 3, because negative 6 can be divided by 3 as well. So I'm going to divide this by 3, and I'm going to divide this by 3. And by doing that, I can actually pull this 3 out of a set of parentheses. And what's left inside is whatever's left after I divide. 3x divided by 3 is going to be x. And technically 1x, but that 1 you don't have to write. That 6 divided by 3 is 2. So that's going to be I'm sorry, this is negative 6 divided by 3. I almost wrote a positive. A negative 6 divided by 3 is a negative 2. So there you have 3 times x minus 2. And then once again, that's what we started with over here. This 3x minus 2 and this 3x minus 2 is just going in opposite directions. This one's going down. This one's basically making your spaceship, right? This is making your spaceship. You're putting the Lego pieces together. And this one here, you're actually taking your spaceship and you're breaking it apart into its various Lego pieces, right? So here you have the cockpit, and you have, like, the 3 might be your cockpit, and this right here is the rest of their spaceship, or whatever. You get the idea. So basically what I'm doing is I'm breaking pieces apart when I'm factoring, then I'm distributing and putting them together. Sorry, I just wanted to have that that kind of foundation. Let's try one more thing of factoring just to make sure we understand it. Let's say we have let's say we have 8x minus 12. So in this case here, if I have 8x minus 12 and I want to try and factor that, right, I'm going to say, all right, well, what factors do I have of one of these here? And my factors for 8 are, right, I'm going to go with my factors for 8 because, first of all, there's a lot less factors of 8 than there are of 12. But also because that's the smaller number, and I'm just going to start with smaller number in magnitude, right? So 1 times 8 gives me 8. 2 times 4 gives me 8, and that's it. Those are the 4 factors of 8. So I'm going to look now and ask myself the question, which of these factors goes into 12? Well, I could start with 2, 4, and 8 and things like that. I could just start randomly, but you always want to start with the largest number first because you want to take out the greatest common factor whenever you're factoring, generally speaking. So in this case here, I'm going to try the 8, but 8, I know all of these factors go into here, so I'm not worried about that. I'm saying, does 8 go into 12, or negative 12 in this case? And the answer is no. 8 doesn't go evenly into negative 12, so that one's out. Then I'm going to try 4. Does 4 go into negative 12? And the answer is yes. Yes, it does. So I'm going to divide this by 4, and I'm going to divide this by 4. This is my greatest common factor that these two have. And I'm going to put my 4 outside the set of parentheses. And inside the set of parentheses, I have 2x minus 3. And I am done. And if I want to know if I'm right, I could always do the opposite, right? If this is the factoring step, which would actually, I should put it on this side with the factoring step, but if I wanted to figure out if it was correct, I would actually just go 4 times 2x minus 3. Oh, that's so ugly. My bad. Times 2x minus 3. And I'm just going to start distributing. 4 times 2x is 8x. 4 times negative 3 is negative 12, right? And so that's 8x minus 12. Now this 8x minus 12 is the same 8x minus 12 that I started with when I was factoring, but now I got it by distributing. Okay. So anyway, you get the hopefully you get the idea of that factoring is the opposite of distributing. Now today we're going to be factoring not binomials. This is a binomial. It has 2 terms here. I'm not factoring a binomial. I'm factoring a trinomial. That's super crazy fun because if we're factoring a trinomial, it means there's not 1, not 2, but 3 terms in it. And so let's go on and move on to what one of those might look like, and then I'll tell you how we're going to do it. We're going to do it with the AC grouping method, which is just one method. There are other methods, but it's one that I like because it actually it's, as you're doing it, it's pretty straightforward, and it works for, I think, every case as far as I can tell. And so let's go ahead and move on to it. All right, so here we go. Yes, I did subject you to that, I'm aware. All right, so 6x squared plus 37x. At this point, I want to say, as always, if you do not have a pen and paper handy or pencil and paper handy, then I highly suggest that you go get one. I will wait. No, really. Go get your pencil and paper. Did you get it? I don't see your pencil. There you go. Thank you. Pencil and paper. Hopefully you did get one, because once again, if you are not actually doing it, you're not learning and you're kind of wasting your time because you just don't retain it. So you need to retain it, and the way you retain it is by actually practicing the problems. So all right, let's go ahead without further ado and without further chastisement. I'm going to go ahead and explain to you how you go and do this problem. So this right here is 6x squared plus 37x plus 6. And the way that we're going to do it, like I said, is the AC grouping method, which is cool. And if you look on your star chart, it tells you that the formula for a the formula for the standard form, for a quadratic equation. This is a quadratic equation because it has a 2 in its highest term polynomial is a 2 second degree, so we would call this a quadratic. And in this case here, I'm going to take and I'm actually going to really quickly, I'm going to just write up the top the standard form of a quadratic equation so you can see where some numbers come from. And I'm actually going to change my color. I want a slightly different color here too. And I'm just going to change my pen size. There we go. So I have ax squared plus bx plus c. This is the standard form of a quadratic equation, right? So a standard form of it. And I want to point out to you a few things. All A, B, and C are just different constants, right? So there's A, B, and C. They're all just different constants. So in this case here, this constant here is going to be A. And sorry, just quickly moving some things around because I don't like the way that's drawing. Okay, there we go. So once again, this constant here is going to be A. This is my A constant. This is my B constant, and this is my C constant, fitting the equation here, A, B, and C. So my x squared term, the coefficient is going to be A. My x term, the coefficient is B. My C term, which has an x to the 0 power really, which is the same as 1, is C. So in this case here I have x squared, x, and C, so this is labeled A, B, and C. And that's important that you realize that because in a second that's going to be very, very, very helpful. Because what I'm going to do with the AC method, I actually take and I'm going to draw this cute little crisscross here. A big giant X, okay? And this big giant X has no significance to the actual mathematical value of this at all. All it is a framework for us to work with to help us solve this. And at the top, what I'm going to have is A times C. So my A times C goes on top, and on the bottom, I'm going to have my B. My B is on the bottom. So A times C is on top and B is on bottom. And so what I'm going to do is I'm going to multiply my A and my C value, which is 6 times 6 in this case. Once again, this 6 is my A, this 6 is my C. So 6 times 6 is going to equal 36. And I'm going to put that here up top, 36. So now I have 36, and here I have B. And my B, in this case, if I look, is 37. So I'm going to make that 37. Okay? So I have 36 and 37. All right, now hopefully you understood where I got all that from. Once again, let me see, I maybe can A times C gave me this 36, and my 37 came to down here. And you could remember this by saying B for bottom. B goes on the bottom, right? But anyway, you get the idea. You have A times C and you have 37 here, right? So you have 36 and you have 37. That won't always be that close, but in this case it is. And what I'm going to do is I'm actually going to, at this point, find all my factors of 36. Because what I'm looking for is I'm looking for two numbers that multiply to give me 36, but that add to give me 37. So in order to do that, I need to find out, first of all my factors of 36. So once again, I'm looking for two numbers that multiply to give me 36, but add to give me 37. So I'm going to start here, and I'm going to say take 36, and I'm just going to do all the factors of 36. So I'm going to start with 1. Always start with 1, because if you don't start with 1, you're kind of just doing it all over the place, and you might just miss some factors that are important, right? And you can use your calculator for this as you go up, but I'm going to just do 1 times 36. 2, I'm going to do 2 times what equals 36? The answer is 18. And if you don't know that off the top of your head, what you can do is you can type 36 divided by 2 in your calculator and get 18, right? 3, how many times does 3 go into 36? 3 goes into 36, a total of my brain just stopped 12 times. So 3 times 12 is 36, and 4 times 9 is 36, and 5 does not go into 36. You could try it. You could try 36 divided by 5. You're going to get a decimal answer, so it doesn't go in evenly. So that's not one of the factors of 36. My next one to try would be then 6, right? 6 times 6 gives me 36. And I actually, at this point, know I'm done. The reason I know I'm done is because I have a factor that repeats. Now, it's not always going to repeat on the same line, but notice I have a 6 and I have another 6. And the reason that's important is because after this point, I could keep going. 7 doesn't work as a factor of 36, neither does 8, but 9 does. 9 times 4 gives me 36. But here, wait, I already have these two factors here. And in fact, if I keep going, I just get 12 and 3, right? And I would get 18 and 2 and 36 and 1. But that's kind of pointless. There's no point in getting all those since we already had them, right? Basically, anything after this point was redundant. So all of this is unnecessary. So I always stop as soon as I get another, repeat, right? So in this case, the 6 and 6 repeat. So what I'm going to do now is I'm looking at this and I'm looking for two of these numbers. These are all my factor pairs. I'm looking for two numbers on the same line that add to give me 37. Well, 6 plus 6 would be 6 plus 6 would equal 12, right? So that doesn't work. How about 4 plus 9? 4 plus 9 is 13. No. 3 plus 12 is 15. 2 plus 18 is 20. 1 plus 36 is 37. So in fact, that very first number I got, I could have stopped right there. That won't always be the case, but you can actually stop once you get a number that multiplies to 36 and adds to 37. So in this case, it's going to be 1, and my other number is going to be 36. And what I'm going to do is I'm going to take and put an X just next to both of those. And now I'm just going to bring down some stuff here. I'm going to bring down this 6x squared, and then I'm going to have plus 1x here, right? I'm adding this, I'm putting a plus 1x, and I'm putting a plus 36x, and I got that 36x from here, right? That 36x becomes this part here, and the 1x becomes this part here, and this 6 becomes the positive 6. And this method looks really confusing at first, and I have a ton of stuff here. I won't draw all this stuff in the future. This is just to kind of help you get set up at the beginning, but basically what I want you to see is the 6x squared I just brought down. The 1x is here, the 36x is here, and the 6x is here. And the whole point of this whole x method and all of this over there, the whole point was to split this number up into something that we can factor with, okay? So at this point, I'm going to group these two terms together, and I'm going to group these two terms together here. And I'm going to ask myself the question, what common factor, what greatest common factor can I take out of this? And if I look at it carefully, I'm thinking to myself, okay, well, there's nothing that 1 and 6 really have in common except for 1. But I have an x squared here and I have an x here, so I can actually factor out an x. Yes, that's as cool as it sounds. So x, I'm going to factor that out now. And basically what I did was I divided this by x and I divided this by x, right? And so I'm left with 6x plus 1. So I have x times 6x plus 1. Now what I'm going to do is I'm going to now do this side here. I have 36x plus 6. And I'm actually going to factor out of this. I'm going to say what common factors do these two have in common? And I'm looking for the greatest common factor. So once again, I'm going to look at my factors of 6. My factors of 6 are 1, 2, 3, and 6, right? 1 times 6 equals 6, and 2 times 3 equals 6. So I'm going to see, does 6, can I take a 6 out of 36? And yes, 36 is divisible by 6, so I'm going to divide both of these by 6. And I get plus 6, right? 6 comes out of the parentheses now. And 36 divided by 6 is 6. I couldn't factor out an x because this one didn't have an x, sadly. So I just I have my 6x now. And 6 divided by 6 is 1. So now you'll notice that something cool has happened. I have this same exact term here. The same exact binomial here as one of my factors. So what I can do is I can actually combine these into one factor, and they become 6x plus 1. And then my outside terms, x and plus 6, become my other factor. Now at this point, if you have not seen this before, you are like, what the heck? What type of devil magic did you just do, Mr. Sims? And I just want you to know that You've been doing this for a very, very, very long time. In fact, you did it in fifth grade. You've probably forgotten doing it, but I just want to show you an example of what you might have done back in fifth grade. I'm just going to take some random numbers. So once again, this is not an actual part of this problem. I just want to show you that this was something that you've done for a very long time. There was a time in fifth grade, I know because I taught fifth grade, there was a time in fifth grade where you did like 27 times 3. And what you did was you might have broken that up in so many ways. What you were trying to show was that 3 times 7, and you did the 21, and 2 times 3 is 6, plus 2 is 8, right? So 3 times 27 is 81. But what you wanted to show was that there was you wanted to see what was happening. So what you might have done was actually split this up into 20 times 3 and plus, and you would have added to that 7 times 3. And you did this. You might not remember doing this, but you did in fact do it. It might have looked slightly different, but this is what you did. You broke it up. You broke this 27 up into its pieces, right? And so you ended up getting 3 times 7 is 21, right? And so what you did when you did that, what you did is you said, all right, 27, you said 27 times 3, right? What you did was you actually split that up into 20 times 3, right? I'm sorry, let me do this a little bit differently just so it looks. You did 20 times 3 plus 7 times 3. Now I hope at this point you're starting to see the connection, the connection that you used to do, right? Yeah, and it didn't look like this probably when you did it, but that's what you were doing when you did that. This is actually this right here, where my 20 and my 7, instead of 20 and 7, I now have x and 6, which I combine to make x plus 6. Just like I combine this 20 plus 7 to make 27. So anyway, I just wanted you to see where that x plus 6 becoming this x plus 6 comes from. Because these factors are the same, because this binomial and this binomial are the same, I can combine these two factors into these two terms into another factor. And so that's like I said, just the same thing. Because this is 20 times 3 plus 7 times 3, I can make that 27 times 3. And like I said, you've been doing that since 5th grade. If that didn't make sense to you, then I want you to erase that from your memory, okay? I'm not trying to confuse you, but I wanted you to understand that you have been doing this particular thing that you just saw, you just didn't realize you were doing it. So in this case here, you have x plus 6 times 6x plus 1, and those are my two beautiful, lovely, wonderful factors. And I'm just going to make sure I got that right. I always want to make sure that I did end it right, that I didn't make a mistake somewhere along the way. And in fact, I am correct. It feels so good. All right, so hopefully that made sense to you. Now, I'm also going to show you that, like I said earlier, factoring is just the opposite of distributing. If I want to make sure I got this right, there's a really easy way to do that. In fact, let me go ahead and just move this down. If I move this down, I can actually take my x plus 6 and my 6x plus 1, and I can multiply them together. I can FOIL them together, and if I FOIL them together, x times 6x is 6x squared, and x times 1 is plus x, right? Pardon me. And this 6 times 6x is going to be plus 36x, and this 6 times 1 is going to be plus 6. So I have 6x squared plus x plus 30. I add these all together, and I get 6x squared plus 37x plus 6. And I see, does that add to my original thing, 6x squared plus 37x plus 6? Indeed, it is correct. And so I know I did it right, okay? So I just wanted you to see that when we did, let me just make a nice line here so you see that this is actually a completely different problem now. What I've done is I've turned this now into a FOIL problem where I'm actually distributing now, right? And so this FOIL, with this FOIL, I just wanted you to see that the whole point of this x thing that we did earlier, the whole point of this x thing was after you FOIL, what happens is these two numbers here, they get combined. This 36x plus this x becomes 37x. It gets combined. And so the whole point of this x thing here is to split this 37x back into its two pieces that we had before they combined to make 37, okay? And like I said, I don't want that to confuse you, but I did want you to see, I like for you to see where the pieces come from, because if you do understand where they come from, it just makes your whole understanding of it a little bit easier. So anyway, let's go ahead and move on from there. Let's go ahead and do another problem. So in the interest of time, so we have 2n squared plus 5n plus 2, and I'm going to once again draw my nice cute little x. And I'm going to have on the top a times c. Remember, this is your a term, your b term, and your c term. I know because the a is attached to the squared term. The b is attached to the end of the one term, and the c is attached to the two term. Now you might be freaking out because this is not an x. What happened to my x's? Well, I just want you to know it doesn't matter what the variable is, and I'm actually going to do multiple variables just to show you it doesn't matter. In this case here, it's n, so we're just going to work with n. So I'm going to do my a times c. My a times c, 2 times 2 is 4, right? And my b is 5. So I'm looking for something that multiplies to two things that multiply to get me 4, two numbers that multiply to get me 4, but add to give me 5. And so in this case here, I'm going to make my I'm going to make my factors of 4. My factors of 4 are 1 times 4 and 2 times 2, right? And I'm done because 2 repeats, and so because if I saw a factor repeat, I know I'm finished. I don't need to do any more. But I was already done earlier too, because 1 times 4 gives me the 5 I need, right? 4 plus 1 gives me 5. So once again, I'm looking for two numbers that multiply to give me 4. They do. And they add to give me 5, because 1 plus 4 is 5. So yay! In this case here, I'm now going to put my 1x here and my 4x here. I'm going to bring down my 2n squared. I'm going to put my 1x here. And once again, the whole point of this x was just to be able to split this 5. Oh, and I said x. It's not x, Mr. Sims. It is 1n. Thank you. Force of habit, right? It's 1n because we're dealing with n here. So it's 1n. And once again, as I said, the whole point of this whole thing that we did here was to split this 5n up into its two terms that I can factor by grouping. So in this case here, I'm going to add 4n, right? 2n squared came down from here, the 1n came down from here, the 4n came down from here, and I'm going to bring down this 2. So this is going to be plus 2. And now I can group these two together and group these two together. It's going to be so much fun. Yes, I did subject you to that again. And in this case, I'm going to factor out an n, and I didn't mean to skip any steps there. What I asked myself the question was, what factors do these have in common? And as you can see, I really can't factor out anything from the, I mean, I could factor out 1, but that doesn't really help me. The only other thing they have in common is n, so I'm going to factor out, I'm going to divide by n, both of these dividing by n. And by doing that, I get n times 2n plus 1, right? And on this side here, I see what can I factor out. And what I'm hoping I can get is this 2n plus 1 here, just so you remember, because it's important to get that, because then I can combine my outside terms, right? So I do factor out they both have in common 2, right? If 2 is my my smaller number in magnitude, I'm saying what are my factors of 2? Well, 1 and 2. In this case, 2, they both have 2 in common as a common factor, so I can take out the greatest common factor of 2. And so I'm going to divide by 2 and divide by 2, and I get, haha, plus 2 times 2n plus 1. And so I get n plus 2 times 2n plus 1. And these terms now can be combined, and these terms can, I can combine these two terms into one factor, these two binomials into one factor, so I get 2n plus 1. And the n and plus 2, the outsides, can now become a second factor all on their own. So I got n plus 2, right? This n became this, and the plus 2 became there, in case you were wondering, okay? And this n plus 2 times 2n plus 1 is my final answer. And as I said before, if I wanted to check it, I could actually do FOIL, and I should get this number here. But I've already worked out some of these before. I just want to make sure I got it right. Yes, and so I did. Now, just so you know, another important thing to realize is it doesn't matter which of these comes first. If, for instance, when I'm factoring out, if, for instance, I got 2n plus 1 times n plus 2, then I can still write it like this. It's the same thing, right? Because with multiplication, it doesn't matter if 2 times 3 is 6, right? But so is 3 times 2. With multiplication, it doesn't matter if you move them around like that. So in this case here, I have, yes, this wonderful, wonderful, wonderful thing. All right, let's go ahead and go to the next problem. Hopefully you got that one right. Let's go ahead and you can try this one out. Now this one's going to be a little bit more challenging than the previous two, but why don't you pause the video and give it a shot? It never hurts to give it a shot and see if you can get it. No, seriously, pause the video and try it. Did you pause the video and try it? I'm beginning to wonder. But yes, in fact, if you did pause the video and try it, hopefully you got the right answer. In this case here, I'm going to do my x, and a times c is my answer here, and b is my answer here. And as always, I do suggest that you pause videos and give them a try, because if you're watching me do it, it's really easy while I'm doing it with you, but it's a lot harder when you have to do it flying solo. So just make sure to pause the video and do give these a try as we go on. So in this case here, I look at my a times c. Remember, this is your a and this is your c. So a times c is going to be 3 times, don't forget this is a -5, right? So 3 times a -5 is going to be a -15. And that's going to cause not some problems, but a little bit, make it a little bit more challenging. And the -2 is going to be my b, so I'm just going to put that there. So once again, I'm looking for two numbers that multiply to give -15, but add to get -2. So here's what I want you to do. I want you to think about what are the factors of -15. I'm going to go ahead and let you think about that real quick. So the factors of -15 are, let's see, I can multiply 1 times -15 to give me -15. But I can also multiply -1 times 15 to get -15. So when you have a negative number, unfortunately, you have twice the number of factors. It is, yes, a pain in the bottom. So we're going to go ahead and do it, though. So there's no, this isn't divisible by 2, but it is divisible by 3. So 3 times a -5 is going to give me -15. Also, -3 times 5 is going to give me -15. All right. The next one, 4 it's not divisible by 4, but it is divisible by 5. But look, we already have 5 here, so we know that we are done. At this point, anything else that we get is going to be a repeat. So these are all the factors of -15. Now, once again, I am looking for two numbers that multiply to give me -15. All of these number pairs would multiply to give me -15, but they have to add to give me -2. Well, -15 plus 1 is going to be -14. That doesn't help me. Likewise, this is going to be +14. That doesn't help me. This one, -5 plus 3 is going to be a -2. That would work. But also, -3 plus 5 would be a +2. I want the -2, so I'm going to choose this one here, because -5 plus 3 is going to be a -2, right? In case you want me to see me do that, -5 plus 3 equals -2. And that -2 is what I want this to be. So once again, I found two numbers that multiply to give me -15, but add to give me -2. And so I'm going to put 3x on this side and -5x on this side. I'm going to bring, oh, it's not x, Mr. Sims. It is p. So that's 3p on this side and -5p on this side. Yes, and so what I'm going to do is I'm going to bring down just some numbers here. I'm going to bring down 3p squared, or bring down some terms rather, and then I'm going to have plus 3p minus 5p minus 5. And so now I'm going to group some terms together. Uh-oh. I think kind of froze on me a little bit. Whoa, that was weird. All right. And I'm going to group these two together. And so I'm going to say, what are some common factors that I can take out of here? And the factors that I see, I can, well, 3 and 3 definitely match up, right? And I can also take out a p. So I'm going to divide both of these by 3p. And divide this also by 3p. And that's going to give me 3p on my outside. I factored out the 3p now. And inside, after I factor out the 3p, I would have p plus 1 left, right? So 3p times p plus 1, and on this side here, I say, what can I factor out of these? Well, remember, I am trying to get p plus 1, so technically I could factor out a 5, but I want to actually make sure that I get this plus 1 here. So how could I get the plus 1? If I factor out 5, if I divide by 5, right? If I divide by 5, I would end up getting plus 5 times a negative p minus 1. And that is not what I want, because I wanted these to be the same so that I could end up combining these outside terms. But I can't do that as it is. So 5 is not actually my solution. I don't want to pull out 5. Instead, I want to think to myself, okay, because this is positive 1 and I want to get a positive 1 here, what would I have to pull out of my negative 5? I would have to pull out a negative 5 in order to get my positive 1. So I have to divide by negative 5 there and divide by negative 5 here, right? So when I do that, I get, I pulled out the negative 5, so I put that on the outside, and this becomes p plus 1. And now, because these p plus 1s are the same, I can do that cool trick that I learned all the way back in 5th grade, where I combine these terms, 3p minus 5 times p plus 1. And so 3p minus 5 times p plus 1, let's see if that is in fact the right answer. And eureka, we did get it. Yes, gagne, as they would say in France. This is the correct answer. Feels good. Yeah, buddy. All right, so we're going to move on to the next problem. At this point, I highly encourage you to go ahead and see if you can do it. Always, once again, you want to make sure that you have the your paper and pen handy and that you try the problem. So go ahead and give it a shot. Pause the video. All right, hopefully you did pause the video and actually give it a shot if you didn't do that now. This is the 4n squared minus 15n minus 25. I'm going to go ahead and make my beautiful little x here. On top, I'm going to have a times c. On the bottom, I have b. And so once again, I'm looking for two numbers that multiply to give me, well, let's see. 4 times negative 25 is going to be negative 100, right? And b is negative 15. So I'm looking for two numbers that multiply to give me negative 100, but add to give me negative 15. So I'm going to put my negative 100 over here, my AC over here, and I'm just going to find out the factors of negative 100. Now, I'm going to cheat just a little bit because I don't like writing all those double factors. I'm just going to remember that, hey, my things have to multiply to give me negative 100. So one of these factors of my factor pair has to be a negative. So anyway, I'm just going to start with 1 times 100 would give me 100, but I need one of those to be negative to get the negative 100. 2 times 50 would give me 100, but once again, I need one of those to be negative to get the negative 100. 3 doesn't work. 4 does work. 4 times 25, right? Let's see. 4 times 25, 5 works. 5 times 20 works. And actually, I can actually stop there, because if you think about it, 5 times 20, if I remember one of these has to be negative, that's going to give me this 15 that I'm looking for. But remember, I want a negative 15. So I know that this is going to be my thing, but my question is, which one of these has to be a negative number in order to get negative 15? Well, my answer is 20 has to be the negative one, right? Because negative 20 plus 5 is going to equal negative 15. So it has to be that my 20 is the negative number. So I'm going to put the negative 20n on this side, because remember we're working with n, and I'm going to put 5n on the other side. And hopefully that didn't confuse you. Once again, I just didn't want to write all the factors, all the 1 times the negative 100 and the negative 1 times 100. If that is easier for you and it's easier for you to keep track, then by all means, please do exactly what we did on this last problem over here, where we wrote all the negatives and positives of it. But in this case here, I just decided, you know what, I just know that I need to get a negative number when I multiply them together, so one of these has to be negative. So in this case here, anyway, I have my negative 20n and my 5n. I'm going to bring down my 4n squared. I'm going to bring down my 25. So this is 4n squared plus 5n minus 20n minus 25. And this right here, if I factor this out, I end up getting the only thing I can factor out, 4 is my smaller number, right? So I'm looking at this 4 and I'm saying, okay, what are the factors of 4? 1, 2, and 4 are the factors of 4. Well, 4 doesn't go into 5 evenly, neither does 2. So the only thing I can factor out of this, unfortunately, is 1. But I also can factor out an n, right? I'm sorry, I'm taking these two here. Let me do that one more time. I'm taking these two here. So I'm going to pull out of these two. I'm going to divide them both by n. And this becomes n times 4n plus 5, right? And then I'm going to take these two terms here, and I'm going to say, what can I pull out of these two terms? And if I think about that carefully, I'm like, okay, well, 20 has some factors in common, right? My factors of 20 are really negative 20, but in this case, I'm just going to say, what are my factors of 20? 1 times 20, 2 times 10, 4 times 5, right? 3 didn't work, by the way. And so I'm looking at what are my factors that these have in common. Well, 20 doesn't go into 25 evenly, neither does 10, but 5 does. So it looks like I'm going to take out 5. But once again, if I take out 5 from this, if I divide this by 5, I am not going to get the positive 5 that I'm looking for. So what that tells me is I actually have to divide this by a negative 5, that I have to factor out a negative 5. So I'm going to factor out my negative 5 here, and that's going to be 4n plus 5, right? And as you can see, this is good news for us, because this 4n plus 5 is now this 4n plus 5, same thing. And so I can actually combine my outsides to get n minus 5 times 4n plus 5. Aha! And so hopefully that's been wonderful for you. You're getting the hang of this, all right? But these are the factors of that, all right? Hopefully you have been making a lot of progress with this. Let's go ahead and see nothing else over here. Let me bring down to here, okay? So here's the next problem. Why don't you go ahead and pause it and see if you can get it. We only have a few more after this, I think 3 more. And then we have some challenge problems that you can tackle if you want. But here we go. So let's start 3n squared minus 8n plus 4. Go ahead and give it a shot. Hopefully you paused the video and gave that a shot. And what I'm going to do, once again, I'm going to draw my X. I want to change my color because I'm kind of getting tired of that color. So let's just go ahead and make this a beautiful green. And I'm going to go ahead. Oh, that's very nice. Sort of lubrious. I love it. Okay. So, yes, I did say the word salubrious. It did. Yeah. So, A times C is 3 times 4, which is 12. And B is negative 8, right? How cool is that? I don't know why I said that. I just did. So 12 is the greatest. 12 is the number I want to find two numbers, sorry, that multiply to get me 12, but add to get me negative 8. So in this case here, let's see. 12, I have 1 times 12. I have 2 times 6. I have 3 times 4. And you're looking and you're probably thinking to yourself, 2, 3, 4. Yeah, that's basically it. I mean, those are my options. Now, you're probably thinking to yourself, here, wait, I have a problem because I have a number that I have to get this 12. Sorry, I have to get this 12 here. I have to multiply to get 12, but I have to add to get negative 8. Well, if I make any of these numbers negative, just one of these numbers negative, like negative 2 plus 6 is going to be a positive 4, right? That's not going to work. And in fact, that's going to give me a negative 12. So I can't make one of these numbers negative. And if you thought that, you're absolutely right. You can't make one of those numbers negative. You have to make both of the numbers negative. Because remember, a negative times a negative is a positive. So in this case here, I think to myself, okay, what if this were negative 3 and negative 4? Negative 3 times a negative 4, right? I'm sorry, negative 3 times a negative 4 would be a 12, right? But it doesn't add to give me negative 8. In fact, it adds to give me negative 7. Negative 2 times a negative 6 would equal a positive 12. And in fact, the nice thing about that is negative 2 plus negative 6 is the negative 8 that I'm looking for. So this is negative 2x, and this is negative 6x. And I'm going to go ahead and bring down my 3n squared minus 2x minus 6x plus 4. And if you did that, hopefully this is making perfect sense for you. I'm going to go ahead and group these two together, and I'm going to group these two together over here. And if I do that, I get, I'm going to say, what's my greatest common factor I can take out of here? Thinking about that, the only thing I put x. I'm sorry, these are supposed to be n. Sorry, I didn't want that to confuse you. These are supposed to be n because we started with n's. So in this case here, I'm going to say, what are my factors that I can take out of here? The greatest common factor I can take out of here is n. 2 and 3 don't have any other factors in common except for 1. So I'm just going to take out an n. I'm going to pull out an n by dividing both of these by n. So I'm going to factor out my n, and I get 3n minus 2. So on this side here, I'm going to say, what can I factor out of here? And the factors of 4 are 1, 2, and 4. So I'm going to see which one of those are divisible. 6 is not divisible by 4, so that doesn't help me. I can pull out a 2, so I'm going to divide by 2. But remember, I want to get this negative 2 at the end. The way I'm going to get this negative 2 at the end is actually by not pulling out 2, but pulling out a negative 2. So I want to divide by a negative 2, because 4 divided by a negative 2 would give me this negative 2 term that I'm looking for. So this is going to be negative 2, right? Well, I don't know why I drew it like that. Let me just draw it from the front. So I'm going to pull out the negative 2. I'm going to factor out the negative 2. So minus 2 times 3n minus 2. Now once again, because I have 3n minus 2 here and here, I can combine those. They become one factor, and I have my n minus 2. That becomes yet another factor. So I have n minus 2 times 3n minus 2, and that's all kinds of fun. Let's see if that is in fact the correct answer, and in fact it is. Now once again, it doesn't matter if 3n minus 2 comes first. These are the same. If it's 3n minus 2 times n minus 2, it's the same answer. So don't be worried if that is the case. But it feels good to get it right. So all right, so hopefully that's what you got. You were able to conquer this. If you did, big smiley face, one-eyed smiley face for you. Yay! All right, moving on. Okay, this one here, I want you to pause it and give it a shot. All right, hopefully you did pause and give it a shot. We have 6n plus 5n minus 6, so I'm going to multiply my 6 times my negative 6, and I'm going to get a negative 36, right? And they have to, whatever I multiply to get that has to add up to get 5, right? So I'm going to start off with my negative 36, and once again, I'm just going to do the factors of 36, and remember that, heck, one of these I have to make a negative number so that I can actually get that negative 36 that I'm looking for. So 1 times 36 does in fact equal 36. One of those would have to be negative once again. 2 times 18, right? One of those would have to be negative again. 3 times 12, and once again, one of those would have to be negative. And 4 times 9, and once again, one of those have to be negative. And I'm actually going to stop there because that is my answer. I love it. There is another factor, by the way. It is 6 times 6, but I didn't need to go that far. I just did. But anyway, I didn't need to because this answer here, 9 and 4, if I make one of those negative, I will get this 5 term that I'm looking for. Now, my question for you is, which one of these has to be the negative? Hopefully you realize it has to be the negative 4 times the positive 9. So this is going to be negative 4n, and this is going to be 9n. And those together are going to get me this negative 36 that I am looking for. So I'm going to bring down my 6n squared. I'm going to bring down my minus 4n. I'm going to bring down my plus 9n. And I'm going to bring down my negative 6. And now that I have that, I'm going to group these together. And I'm going to group these together too. And this I have 6n squared minus 4n. I'm going to say, what can I factor out of these? Well, they have some numbers in common. The factors of 4 are 1, 2, and 4. And in this case here, I can't factor 4 out of 6, but I can factor 2 out of 6. So I'm going to go ahead and factor 2, but I'm also going to factor out an n as well. So I'm going to divide this by 2n, and I'm going to divide this by 2n. And when I do that, I get 2n outside the set of parentheses times 3n minus 2. And that's going to give me all the terms I'm looking for if I were to multiply that together. And then on this one here, I want to get this 3n minus 2. But to get the 3n minus 2, I'm going to have to say, okay, what are the factors of this that I can pull out? Now this time, the nice thing is it's already negative, so I just have to pull out a regular, good old-fashioned 3 to get me that negative 2 I'm looking for. So I'm going to divide this also by 3. And so I'm going to pull out my positive 3 times 3n minus 2. And then the nice thing is, because these 3n minus 2s are the same, they're going to become one factor, and the outsides are going to become the other factor. So 2n plus 3. 2n plus 3 times 3n minus 2. And hopefully that made some perfect sense to you. I hope that you're starting to really get the hang of these. I'm really hoping that we're not confusing you, but this is a fun little exercise in helping you get better at math in general. So this right here is the correct answer, by the way. Let's go ahead and move on to the next problem. Once again, try this one yourself. See if you can do it. There's only one more after this that I would say is kind of mandatory. The other ones are challenge problems, and well, we'll see if you can get them. This right here, go ahead and try it out. Hopefully you did, and you got, I'm going to do orange this time. Why not? Because we can. Hey, look at that burnt orange, you UT fans. I'm actually from A&M, but I'll give it to you. So in this case here, we have 6 times a negative 49. That is so ugly. Oh my word. Okay, let me just do that. 6 times a negative 49. I'm seriously using the calculator for that one. My math skills are good, but I would literally to actually do long multiplication to get that one. Negative 294 is, I can write it here. Negative 294 is what I'm looking for. And so what I'm going to do is I'm going to figure out the factors. I'm going to figure out the factors of 294. And yeah, well, let's do it. So once again, I'm looking for some numbers, two numbers that multiply to get me 7, but add, that multiply to get me negative 294, but add to get me 7. So 1 times 294, that is not going to get me 7. Even if I make one of those negative, because remember, I have to make one of those negative to get the negative 294 that I'm looking for. 294 divided by 2 is let's see. Once again, I'm using a calculator for this because that is a lot of just kind of tedious math to do. That's why we have calculators at this point in your math career, to help with the tedious math, right? 294 divided by 3. Hopefully you haven't become calculator dependent, but it is a good tool to have. 294 divided by 4, does that work? Let's see. Nope, that gives me a decimal answer. 294 divided by 5 I know is not going to work. 294 divided by 6 I know will work because it's divisible by 2 and 3, therefore it's going to definitely be divisible by 6. Hopefully you remember those divisibility rules. 294 divided by 6 is 49. Okay. Does it work with 7? 294 divided by 7, not sure. Yeah, 294 divided by 7, I get 7 times 42 gives me 294. This is an ugly problem. Mr. Sims, where did you find this evil beast? So 294 divided by 8, does that work? No. 294 divided by 9, does that work? No. 294 divided by 10, I know it does not work. How about 294 divided by 11? I don't think that works either. No. 294 divided by 12 gives me, no. 294 divided by 13. 294 divided by 14. Wow, these are getting ugly. Oh, 14 worked. Thank heavens. So 14 times 21 gave me that. And I have good news for you. We don't have to keep going because if one of these numbers is negative, guess what? We're going to get this positive 7. Now, question is, which number has to be negative so that they add up to get 7? I'll give you a hint. It's the bigger one is going to need to be positive to give you that 7, right? So the negative is going to be the negative 14. So negative 14 and positive 21. And since we're using x, yay, we went back to x. So we're using x, we're going to put the x's there, right? And so hopefully that made sense to you. Once again, these two numbers multiply. Well, if one of these is negative, it multiplies to give me negative 294, but they add to give me a positive 7. So now I'm just going to take and bring these down. This is 6x squared minus 14x plus 21x minus 49. And if I do that, I'm looking at this now, it's an evil beast, and I'm thinking to myself, okay, I'm just going to factor these two. And I'm going to factor these two, and out of here, I'm looking at what I can pull out, what I can factor out. It looks like the greatest common factor between this 6 and this 14 looks like, I think it might be 2. So I'm going to factor out 2. So I'm going to divide by 2x actually, because I have an x term that I can factor out as well. So divide by 2x, and I get 2x on the outside times 3x minus 7, right? And then over here on this side, I'm going to factor out 7. So I'm going to factor out 7, but yep, that's it. Just factor out 7, and that becomes 3x minus 7 as well. Because if I divide both of these by 7, I get 3x minus 7. So then, once again, because these are the same, I can take my 2x plus 7, and I can combine them. And that's 2x plus 7 times 3x minus 7. And that is my final answer, I believe. Let me just make sure I haven't made a mistake. And, in fact, I did it right. It feels good. Now, once again, if you had those switched around, it's fine. It still gives you the same answer. All right, so let's go ahead and now move on to our last normal problem before we get to the challenge problems. Let's go ahead and start with this one. I don't like that color anymore. I want a different color. So I'm going to make, let's go purple. So we're going to go ahead and periwinkle is actually my favorite color, but it just doesn't do well with the video very much. So here I have 5n squared plus 19n plus 12, and 5 times 12 is 60. So I'm going to put 60 up here, and 19 is the number that I'm looking for. I'm sorry, 19 is the b. So once again, this is a, b, and c. Sorry, I'm not meaning to skip steps on you. A times c, and this is the b. section. Okay, so once again, I got the 60 from multiplying 5 times 12. So I got my 60 that I'm going to find the factors of. 1 times 60, 2 times 30, 3 times 20, and sorry, my brain just stopped. 4 times 15, and I'm going to stop there because this 4 plus 15 adds up to give me 19. Haha! So since that is the case, I'm going to actually make this 4n, and this is going to be 15n. And once again, we bring down like we've been doing all night long. This is 5n squared plus 4n plus 15n plus 12. All right, and hopefully that would have made a lot of sense to you. And I'm going to group these together, and I'm going to group these together. The only thing I can pull out of this one is n. So I'm going to pull out n, and I get 5n plus 4 plus, in this case here, what can I pull out of here? Well, if I look at it, it looks like 12, the factors of 12 are 1, 2, 3, 4, 6, and 12. I think I might have missed one. But the whole point is these two have one number in common that's really easy to see, 3. So I'm going to divide them both by 3, and I get plus 3 times 5n plus 4. And actually, just to give you a nice little hint, when you're doing problems that we give you, the nice thing about it is you can kind of look at this and say, hey, how would I get this 5n that I'm looking for here? And if you do that, you should kind of just realize, oh, I divide by 3, you know, and you could do that with the 12 as well. So in here, I have 3 times 5n plus 4. So now, because these 5n plus 4s are the same, I can go n plus 3 times 5n plus 4. And once again, that n came from here and that 3 came from there. So n plus 3 times 5n plus 4. I'm sorry, that looks like chicken scratch. Oh my, Mr. Sims, this just gets worse and worse. So let me try that again. Times 5n plus 4. Ah, yes, that is by a goed, as my friends from South Africa would say. What do we have? All right, let's see if there's anything else. No, that's it. So now to the challenge problem. Dun dun dun. You can go ahead and give this one a shot. You might realize something crazy is going on after you try it, but go ahead and give it a shot. All right, hopefully you did give it a shot. Never hurts to try and stretch your brain, but like I said, this is a challenge problem. And what I want you to realize as we're doing this is let's just go ahead and start with my x. And I'm going to go and say, all right, I want something that's going to multiply to get me 1,600. Oh my word. What on earth was I thinking? Okay, so 1,600, right, is A times C. That is so ugly. Why would I do that to myself? All right, I'm just going to do it anyway. 1,600. Ready? Go big or go home. So in this case here, it has to add to get me 60, right? So I'm just going to go ahead and take my factors of 1,600. As I know, this is going to be 1 times 1,600 is going to be 2 times 800. Oh my word, this is going to be 3. I don't think 3 goes into that. No, 3 doesn't go into that. Let me see. 4. Yep, 4 times 400. This is going to be fun. 4 times 400 is going to be 1,600, right? 5 works as well. 1,600 divided by 5, or 1,600 divided by 5 is 320. So 5 times 320, right? And just so you know, there's a lot of factors for this. 1,600 divided by 6, does that work? No. 1,600 divided by 7, no. 1,600 divided by 8 should work. I get 200, so that's 8 times 200, right? And let's see, 1,600 divided by 9 will not work because it's not divisible by 3, so it's definitely not divisible by 9. 1,600 divided by 10 does work. That's 16. What am I doing? 160, sorry. It's going to be 10 times 160 would get me that, and I am getting much closer to something that adds to get me 60. Remember, it has to multiply really to get me negative 1,600, so one of these has to be negative. So let's just keep going here. Oh boy, pain. Okay, so 11 times 16 is not going to work, right? Let's say 12. 1600 divided by 12, does that work? No. 1600 divided by 13, does that work? No. 1600 divided by 14, does that work? No. 1600 divided, did it work with 11? No, it didn't. Okay. 1600 divided by 15. No. Yes. 1600 divided by 15 is or divided by 16, sorry, is going to be 16. Sorry, why is my pen not working? Uh-oh. 16 times 100, right? So that worked. I'm going to keep going. Let's see. 1600 divided by 17 shouldn't work. 1600 divided by 18 doesn't work. 1600 divided by 19. And at this point, you're probably like, Mr. Sims, seriously? And yeah, that's what I'm thinking about myself right now. 1600 divided by 20 does work. You get 20 times 80. And guess what? We are finally, oh my word, we are finally done. And here's the fun part. I'm actually going to show you that there was a much easier way to do this, but I wanted us to feel the burn first. So in this case here, we have 20 times 80. So one of these has to be a negative number to get me this negative 1600 I'm looking for, and to add up to get 60. So which one's going to do it? Well, I want to add to get a positive 60, so 80's got to be the positive number. So that's going to be 80b here, and this is going to be 20b. And if you're thinking to yourself, I probably could not have gotten this by myself. You could have. It just would have taken you some time, right? As I did with my calculator. It was a pain in the bottom, but yeah, I did it. In this case here, I get 16b squared plus 20b plus 80b minus 100. All right. Now, I'm just going to show you now. I'm going to group these two together, and I get 16b squared plus 20b. I'm going to look at what is my biggest thing that I can take out of there. Well, the biggest thing I could take out, let's see. The factors of 16 are, I'm actually going to do them over here. 1 times 16, 2 times 8, and 4 times 4, right? So in this case here, 4 would work. 16, 8 times 2 gives me 16, but 8 doesn't go evenly into 20, so that doesn't work. 16 doesn't work. So 4, it looks like is going to be our winner chicken dinner. So I get not negative. Divide by 4. Thank you, Mr. Sims. You cannot speak today. So I'm going to divide by 4 here, and divide by, what is this? What? My brain just stopped. Divide by 4. Thank you. But I also want to divide by a b as well to get it out. So I get 16b squared divided by 4b, which is going to be 4b, right? Once I factor out 4b, it's going to still give me 4b. So 4b times 4b plus 5, right? Once I divide that by that, I get 4b plus 5. And then on this side, I'm going to do the same thing. I'm going to go ahead and say, all right, I'm going to factor out some things here. So once again, I have 80, pardon me, 80b minus 100. I'm going to factor out, let's see, what do they have in common? I could factor out 10. I could factor out 10 from both of them. So if I factor out 10, I think that might be the biggest one I can factor out of both of them. Let me see. Yeah, factors of 100, factors of 80. I have 1 times 80. Here, let me do it over here. I have 1 times 80, factors of 80, right? I have 2 times 40. I have 3 doesn't work. 4 does work. 4 times 20, right? 20 actually could be a factor. I did not consider that one. So 20 is going to work. 40 is not going to work. So since 20 I know is going to work, I don't need to continue any further because I know 20 goes into both of those. 40 is not going to work, neither does 80. So in this case here, I'm going to take and divide this by 20, and I'm going to divide this by 20, and I get plus 4. Sorry. I'm going to pull out my 20 now. 20 times 4b 4b plus what's this? 4b, my brain just stopped. 4b plus minus 5. Sorry. Thank you. No? What did I do wrong? I did something wrong. What did I do wrong? Oh, I forgot to make one of these a negative number. That's what. The 20 was supposed to be a negative 20, which was I made a mistake. So here we go. This ends up being negative 20 here. When I divide by 4b, this is a negative 5 here. That's what I did wrong. Okay, so when I factor out the 20 here, this is going to be a negative 5, right? So, all right, hopefully that didn't confuse you too much. Sorry, that's what I messed up. I forgot to make that a negative 20 over there. So, okay, so when I factored out the 4b from this, and I got 4b minus 5. I factored out the 20 from this, and I get 20 times 4b minus 5, right? Now I'm going to combine some stuff. I go 4b, because these are the same, I can combine 4b plus 20 times 4b minus 5. And at this point, just so you know, if you got this answer, you are almost right. You're almost right, but you're not right. Because at this point, I still need to take and factor out something more. What I need to factor out is I need to factor out from this 4b plus 20, I need to factor out another number, because this still has common factors. So what I'm going to factor out is I'm going to divide both of these by 4. And that gives me 4 times b plus 5 times my 4b minus 5. And I don't know why I started to come up with an upslant here. And that right there is my final answer. Is my final answer because what I've done is I've actually completely factored everything that I can. At this point, none of these can factor anymore. So I have 4 times b plus 5 times plus 4b minus 5. Now, what I wanted to show you, I said, hey, this was a pain in the bottom, right? And the truth is, like I said, this is a challenge problem. And what I could realize, we haven't given you anything like this yet, but what I wanted you to realize is if I'd just taken just a second to really think about this early on, I could have saved myself a lot of trouble. What I could have done, I could have taken, I'm just going to rewrite my problem on the bottom. If you don't mind, I'm just going to rewrite 16b squared plus 60b minus 100. So let me just go ahead and write it down here. So once again, that's 16b squared plus 60b minus 100. What I could have done to make this a lot easier for myself is I could have realized, hey, I can factor out of all of these a 4. And this 4 that I'm factoring out is this 4 that you see right here. And I could have factored a 4 out of all of this at the beginning. And we're going to teach you how to do that. If you don't know how to do that now, that's okay. You're just getting a little bit ahead. So this would be, if I divide all of this by 4, right, which I can do. If I divide all of that by 4, I get 4b squared plus 15b minus 25. And if I did that, now I can use my x method to factor this puppy on the inside. And if I do that, now it's going to be way simpler. 4 times negative 25 is a negative 115 here. And so I have to find two things that multiply to give me 100. So once again, I'm going to go 1 times 100. Now, just so you know, this is way simpler than finding all the factors of negative 1,600. So look, just factoring out that 4 at the beginning really helped me out. So I'm going to go 1 times 100, 2 times 50. Remember, I'm trying to find something that gives me 15. So or that add up to get 15, but one of these has to be negative to get me the negative 100. So 3 doesn't go in there. 4 does. 4 times 25, right? 4 times 25 is going to give me 100, but that doesn't work. 5 times 20. 5 times 20 is going to give me the 15 that I need. If one of these is negative, which one's going to be negative to give me 15? That's a negative 5. Negative 5 times 20 gets me the 15 I need. So this is going to be negative 5b, and this is going to be positive 20b. And cool, now I can actually bring down this 4b squared minus 5b plus 20b minus 25. And if I do that, now I can see that I can actually take this and group these together and group these together, and then I'm going to find the common factors. And I'm going to pull out a b here. B times 4b minus 5, and I'm going to pull out from this one a let's see, a 5 times 4b minus 5, and so that becomes b plus 5 times 4b minus 5. And we're almost done. The only thing we have left to do is, remember, we were multiplying this times that, so I have to just put my 4 on the outside. And this is my final answer. And as you can see, it's the same final answer that I got up here. 4b plus 5 times 4 times b plus 5 times 4b minus 5. I got the same answer. The only difference was in this one on the top, I had to do a lot of extra work and have to deal with some very large numbers, and I saved myself a lot of effort just by realizing that, hey, I can actually factor out this 4 at the beginning. So when you can factor out things like that, it's going to help you out in general. I just wanted to show you that it was, like I said, a challenge problem. I'm going to give you another challenge problem. You can, you don't have to do these. These challenge problems are just for you if you just want to, test your math muscles. Yeah. So okay, so go ahead and look at this one and think, is there anything that I can factor out of all of these? Well, my smallest number of these is my 9. So what I'm going to do is I'm going to look at my factors of 9. 1 times 9, 2 times, 2 doesn't work. What am I thinking, Mr. Sims? And 3 times 3, right? 1 times 9 and 3 times 3. So I'm going to see, does 9 go in all of these? 9 does not, unfortunately, go into 66, right? Nothing. If you try and divide 66 by 9, you get an ugly decimal number. But 3 goes into all 3 of these. So what it tells me is I can actually factor out at the very beginning. If I divide all of these by 3, I can save me a lot of time in the future, in the near future here, by just factoring out that 3 at the beginning. And so I end up getting 3k squared plus 22k plus 7. My dog is making strange noises next to me, and it makes me nervous. Okay, so 21 divided by 3 is that 7. So anyway, now this is a much easier thing for me to factor as a trinomial. A much easier factor, a trinomial for me to factor. So 3 times 7 is 21. 22 is going to go on the bottom. So once again, I'm looking for two numbers that multiply to get me 21, but add to get me 22. So if I look for 21, 1 times 21, well, that multiplies to get me 21, and the good news is it also adds to get me 22. So I'm going to put 1k here, and on this side I'm going to put 21k. Once again, I'm going to bring down my 3k squared plus 1k. It's hard for me to draw a k so small. K plus a 21k. What is Mr. Sims doing? Mr. Sims. 21k, sorry, this should be a k by the way, plus 7. And then once again, I'm going to group these two together, and I get k times 3k plus 1. And over here, I get plus I'm going to factor out the 7, plus 7 times 3k plus 1. Once again, I divided this by k. I divided both of these by k. I didn't show it, but that's what I did. And over here, I divided both of these by 7, okay? And so I have k plus 7 times 3k plus 1. And if you got that, that's good, but it's not right because you need to remember this 3. And I have to put the 3 on the outside. And that is correct because I factored that 3 out at the beginning. So 3 times k plus 7 times 3k plus 1 is my answer to that. And hopefully that was super cool. Hopefully you're having a lot of fun. All right, there's one more challenge problem that you can tackle if you want. And here's that final one. Final challenge problem of the night. On your marks, get set, and go. Hopefully you did pause the video and hopefully you were able to find some common factors that did make this easier in general. So the common factor I'm going to pull out of this, it looks like the common factors of the factors of 6. In fact, it's got to be -6. I'm going to look at the factors of 6 though, and just remember that one of these, I'm looking at my factors of 6. It looks like 1 times, what am I doing? Mr. Sims, 1 times 6 and 2 times 3. So I'm going to factor out of this I noticed that these aren't all divisible by 6, but they are all divisible by 3, right? 3 times 5 is 15, 3 times 9 is 27. So once again, your math facts help if you learn those. So I'm going to divide all of these by 3. Divide by 3. And that's going to give me 3 times, once I factor out the 3, I get 5n squared minus 9n minus 2. And as you can see, that is way, way, way easier than trying to do this up here. And so I'm looking for, I'm going to draw my x, and I'm looking for my factors of -10, right? And I'm looking for the factor pair that adds up to give me a -9. So I'm going to once again just do my factors of 10 and just realize that one of these has to be negative in order to give me the -10 I'm looking for. So 1 times 10 is 10, and I can stop there because 1 times 10 does give me 10, and if one of those is negative, I will get a -9. Which one has to be negative to get that -9? The answer is -10. So I'm getting -10n, and I'm going to get 1n on this side, and this is 5n squared minus 1n, plus 1n, minus 10n, right? Minus 2, because I'm going to bring down the -2 from here. And now I'm going to group these together and group these together, and then we'll get a fun little thing at the end. And let's see what we got. We get, pull out an n, and I get 5n plus 1, right? And over here I get minus, I want to get 5n plus 1, so this has to become positive. So the way I'm going to do that, I think, is divide out a -2. I'm going to divide this by -2, and that should give me that positive 1 that I'm looking for. So I'm going to pull out a -2 times 5n plus 1. And the nice thing is, because these 5n plus 1s are the same, I now have n minus 2 times 5n plus 1. And I hope that made sense to you. I hope you had some fun learning tonight. I know this video is probably really long. It takes a while to do factoring trinomials, but I'm hoping that you were able to conquer it. And I hope the challenge problems were exciting for you, and hopefully you got even a little bit ahead where we're at right now. Let me make sure I did get that problem right. I think I did. Oh, look what I almost forgot. I almost forgot to bring that 3 down. Oh, caught it in the last minute. So let's see here. 3 times, where's my problem? 3 times, where's my 3? Did I get it right? Where's my problem? Okay, I can't seem to find that problem right now. There it is. 3 times 5n plus 1 times n minus 2. Yep. And once again, all they did was switch these around. So I'm good to go. I have the right answer. That feels good. All right. Anyway, just wanted to let you guys know it's been a pleasure teaching you tonight. As always, I love helping you out. I love seeing you learn. Most of all, I want to just commend you on being that person who really goes after it. I want to give a shout out to the young man today who came into my classroom. He asked me, he said, Mr. Sims, he said, when are you making another video? And I said, I'm going to make one tonight. And he said, and then as he was walking off, I asked him, I said, you know, have you been watching the videos? He's like, yeah. I said, which ones? He said, I watched all of them. And that just made me really happy. Number one, it made me happy on a number of levels. First of all, that he's looking for another video because he wants to learn. But the other thing, I just want to commend that young gentleman. I'm sorry, I forgot his name. Otherwise, I'd actually give him a proper shout out. But I just wanted to commend him because, man, that type of effort is the effort that's going to carry you a long way. When you're willing to say, I'm going to do whatever it takes for me to be successful. And if it takes me watching a video and working the problems out to be successful, and I'm going to take charge of my learning that way, then I'm going to do it. And so shout out to that young man. Shout out to any of you who are also doing it. I know there's a lot of you who have taken the opportunity to learn. I wish you the very best. You're wonderful. As always, you're wonderful, wonderful people. And I wish you the best in all your endeavors. Good luck on your next test, and have a great, 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 great week.